have noticed there was a bit of a theme with this morning in that we were talking a lot about Rust and C, C++. We are continuing that conversation for the next block of content that we have for Oxidize. And we're going to start off here with Nicolas Fella from KDE, which is a programming community. They make software, or just software. And they're traditionally we're operating in C++, but Rust is starting to creep in. So to tell us about that, Nicolas Fella, everyone. Thank you.
So, welcome back from lunch. First of all, apologies for not having a crustacean on the slide, but that's because I come from the land of dragons, which is KDE. Who of you has heard of KDE? That's very nice. So we are an international community of people creating free software. We are probably most famously known for the Plasma desktop environment on Linux, but we also create loads of cross-platform applications like Krita, which is our digital painting application, Kdenlive, which is a very powerful video editor, and a bunch more. And our software runs in various organizations and governments, and you might even have used some of our code without even knowing that. So traditionally, we come out of the Linux desktop ecosystem, but we have since grown and extended more towards other platforms like Windows, macOS, Android, and so on. We've been doing this for a while. We started out in 1996, so ever so slightly before I was born. And over the last 30 years, we had about 7,000 individual people who have contributed to the project, and about 150 of them met last week here in Berlin for our annual conference called Academy, where Rust was also a big topic there. And the whole community is backed by a non-profit organization called KDEV, which is a non-profit under German law. And it takes care of some of the legal and financial matters behind the community. And one of the things that it does is it pays some people to work on this open source software, including me. So a little bit about me. I actually have 2 day jobs. One of them at KDEV, where I'm the software platform engineer, meaning I take care of common building blocks that you will find across different KDE projects, like our UI framework and associated libraries. And it's my job to make sure that those work great and people can create awesome software. I also have a second day job as a consultant, software engineer, and trainer at KDE, where I also work with C++ most of the day. I live in southern Germany. I've been contributing to KDE since about 2017. And every couple of years, the community gets together and elects some goals that the community wants to focus on for a certain period of time over a couple of years. And last year, we chose the streamlined application development experience goal, which is all about creating nice APIs and opportunities and tools for people to create applications, where I'm serving as the gold champion, and where part of the goal is improving the support for Rust within the KDE ecosystem. So a little bit about our software. We have about 1,000 internal projects, applications, libraries, and so on. And in total, that comes to about 15 million lines of code, which probably makes us one of the more bigger open source projects out there. Most of that code currently is C++, and most of it is also based on the Qt UI framework that we use throughout our code for all of our UI and application needs. That also comes with its own declarative UI description language that is sort of similar to something like HTML plus CSS and a bit of JavaScript. And we're using CMake as our build system throughout KDE software. And within the projects, we have loads of internal libraries and APIs that are shared between all of the different applications. So I'm going to spoil a bit the rest of this talk by saying we're not going to rewrite all of those 15 million lines of code in Rust. If we tried that, I could probably present the result to you at Oxidize 2075, but I plan to be retired by then. But since we're not going to rewrite everything in Rust, why am I here speaking to you at a Rust conference, you might ask? Well, Rust certainly is a very interesting language for us. And talking to you about the benefits of Rust feels a bit like preaching to the choir, which would actually be very adequate since we are in an old church building here. One of the primary flagship features of Rust is memory safety. That is, of course, a very important topic, but coming from a KDE perspective, it might not be as interesting for us as you might think it would be. At least if you look at it through purely a security lens. So why am I saying that? If I look at the number of security advisories and CVEs that we have published over the last 30 years, you will find it's actually not that many. And if you look more into detail, actually most of them aren't directly related to memory unsafety. Does that mean we have found the magic secret sauce to writing crash-free C++ code? No, unfortunately it does not. Our software still crashes, but not every crash is necessarily immediately a security vulnerability. But still, we want to avoid crashes because they are annoying for the user, annoying for the developer to debug, and Rust certainly has a lot to offer there that helps us write software that crashes less. However, at the same time, it very much depends on how you write and structure your Rust program. Because if you, for example, just call unwrap all the time, then your program will probably, on more than one occasion, just panic. And while that is probably not exploitable in a security sense, from a user's perspective, it doesn't really make a difference if it's segmentation faulting or panicking. Both are annoying for the user. I think the benefits of Rust go much beyond just the pure memory safety, because in many ways it's just a more ergonomic and attractive language to use, because the APIs are designed in a more consistent way. It has some really interesting principles, some of which you will also find in what we call modern C++. So if you approach Rust from the perspective of someone who has been working with C++, and particularly modern C++, you will find a lot of similar concepts and ideas, except that with C++, they tend to be sort of tacked on top later on top of the older things that we don't really want anymore, but can't get rid of. And Rust is often described as, what if we took modern C++, took these principles and applied them consistently and with better defaults? And I think there's a lot to that. Generally, Rust tends to have a much nicer to use tooling than C++ offers when it comes to build systems and dependency management and so on. And particularly the dependency ecosystem in Rust is very attractive because there's loads of crates available for all sorts of tasks, and it's very easy to incorporate them into your build. And all of that makes Rust a lot more attractive language for potential new contributors to the community, which is very important to us. So now that we have established that Rust is very interesting, we probably want to use it, but we're not going to rewrite all of that overnight. We have to somehow mix those two languages. So how do we do that? Out of the box, Rust comes with interoperability with C via a C ABI. And given that C++ descends itself from C, it's possible to do interop with C++ that way. However, if you do that, you will very quickly notice that Rust has some high-level concepts like optionals, vectors, boxes, and C++ has some high-level concepts like optionals, vectors, unique pointers, and those concepts tend to match fairly well with each other. However, those concepts are not found in C. So whenever you want to interact with these high-level concepts, you have to break it down onto something that you can transfer via a C ABI, go to the other side, and then build them back up again. That's very much possible. However, if you do that for a while, you will very quickly find it very tedious, and you will wonder, is there a better way for that? And as it turns out, there is. For example, there is the CXX crate that allows for exactly this kind of high-level interoperability between Rust and C++ that internally still uses a C ABI, but it does all of this heavy lifting of breaking down and building up these concepts for you, and you don't have to worry about that. And just by the way that CXX is structured, it allows you to write relatively safe bindings. Now, since we are also working with Qt a lot, and Qt brings its own types and concepts and ideas to the table, we also want something that makes Qt and Rust interact with each other. And for that, my colleagues at KDE are maintaining the CXX Qt crate, which takes the ideas and concepts from CXX and applies them on top of Qt and allows you to interact with Qt types from Rust and vice versa. And since we in KDE have a lot of own APIs, we are also building on top of CXX and CXX Qt with the CXX KDE frameworks crate, where we create bindings for our own internal libraries. Now, before we get into more of the details and pitfalls of this CXX interop, we need to establish some basic concepts. Whenever you expose a type in a CXX bridge, it can be done in one of two ways. One of them is via shared structs, the other one is opaque types. Shared structs means you basically have, on both language sides, a struct that represents your data. If you have a very simple type, for example, a point that is defined by an x value and a y value, you can very easily represent that in both languages, and the integration between them is fairly seamless. And the Rust type will feel like a Rust type is supposed to feel. However, not every type can be represented that way, because it's, for example, defined in C++ in some convoluted way, and it doesn't magically nicely translate to Rust. Then you have to treat it as an opaque type, which means that within Rust, you cannot directly pass it by value. You can only pass it via some sort of indirection, like a reference, a pointer, a box. And it doesn't really feel like a proper Rust type, which limits your joy when using that. So we have many real-world types that we would like to use as value types, because that's what we do in C++, but we can't really do that easily with CXX out of the box, because they don't immediately qualify for being trivial or shared structs. So how can we get out of that? So one thing that is true for any Rust type, by default at least, is that you can move it, meaning I can take the bytes for a specific object, copy it around the heap, and it will stay the same object, and you can interact with it. If that's not the case in Rust, you will notice, because then you will need to use, for example, a pin for it, and it suddenly becomes a very different feeling type. C++ also has move semantics, but that's something else entirely, and is a topic that can fill entire books, so I'm not going to get into that. And C++, as in the standard, doesn't really have any concept or understanding of copying bytes around. However, as Qt framework developers, we have discovered that many types that we deal with actually have this property that we can copy the bytes around, and we just call that by a different name. We call that relocatable types, or call them trivially relocatable. And we can exploit that and use that to make those types trivial in a CXX bridge. And CXX Qt very heavily relies on that to give you an idiomatic and natural feeling Rust API. I see Leon nodding, that's a good sign. However, trivial relocation is not very trivial, unfortunately. It's an idea that works fairly well on paper. In practice, Leon and I have run into trouble with that. And that partially has to do with things like how specific operators in C++ are defined or implemented. And there's also an additional catch, which is if you have a polymorphic type, so something with a v-table in it, on some ABIs, like the relatively new ARM64E ABI, that pointer has a special authentication to it as a security feature, meaning that on this specific ABI, you cannot trivially relocate, so copy around a vtable and by extension a polymorphic type, which is very much not obvious and a huge pitfall in there. So how do we get out of that? There is some work ongoing in the C++ standards committee to actually have a definition of trivial relocatability and some understanding of it in the standard. And my hope is that we can use that to put this sort of interop between C++ and Rust that we do here on a more solid theoretical foundation than what we have right now. Is that the only problem? Unfortunately not. There's also still some challenging or unsolved problems when doing this kind of interop. One of them is with generic programming. In Rust, we have the system of generic programming via traits. In C++, we have templates. And those concepts mix relatively well with each other in principle. However, it's really hard or next to impossible to actually do that as you might want to in a CXX bridge. So for example, what we do in CXXQt is we have a Q vector type that in theory is generic over anything you might want to put into, but what we have to do is have specific specializations for every type you want to use, and that's not very good, obviously. Another area that one can spend a huge time looking into is just asynchronous programming with things like Tokyo, event loops, coroutines, and so on. But it's also something that's very important to solve because asynchronous programming is very nice and very important. And then whenever you do this sort of API bridging, the API on the Rust side or the C++ side is not necessarily idiomatic, and it is always somewhat driven by the implementation details of the other language. And that's unfortunate because we as Rust developers want our APIs to feel nice and Rusty. And a bit of a general problem with CXX seems to be that upstream development seems to be somewhat stagnant in the sense that there's features missing that people want and in theory would be able to implement, but upstream is sort of dormant in taking up these things. I don't want to speculate on the reasons for that too much, but it just strikes me that such an important piece of the story of integrating C++ with Rust could use from more community involvement from both the C++ and Rust communities that goes beyond a single maintainer. Taking a step back, where does Rust even fit in within the KDE ecosystem? I personally don't think, and many people who I have talked to agree with me on that, is that for like high-level application programming, like let's take a push button, push it into a layout, push that layout in a page, in a container, in a window. This is not where Rust is shining, and more often than not, it just gets in the way. Where Rust really shines is towards the lower levels of the application stack, whenever you have things like file parsing, file I/O, data crunching, serialization, deserialization. This is where Rust really shines and where we have good tools to make hard stuff actually less hard. Also, gradually rewriting things function by function or class by class can be very hard depending on how your interfaces are designed and how well they map onto what CXX supports. And also, many problems that I might be able to nicely solve in Rust have already been solved within KDE for 30 years or 20 years, and I don't need to touch that code. If it just works, who cares if it's C++ or Rust? It works. Where I think Rust makes the most sense is whenever we are creating bigger batches of new code, like new applications, new subsystems, new modules, where we have, first of all, a bigger block of just pure Rust code, and the interface that we need to create bindings for to the C++ side are fairly minimal and controllable. And in particular, Rust makes a lot of sense when there is an interesting trait we can leverage for a task that we have not figured out yet. And that is, in fact, where most of the existing Rust code in KDE, yes, we already have a bit of Rust code in there, can be found. For example, we have in one of our web browsers and in KDE PIM, so our email and groupware client, we have a need for ad blocking. And for that, we are using a crate for ad blocking that maintains block lists and the management thereof and so on. Also, in another place in KDE PIM, we have a need to parse HTML, which is something that is very hard to do in a fast and secure way. So we're using an HTML parsing crate for that. And recently we started working on a new theming engine and now have a need to parse and handle CSS code. So we're using a CSS crate that comes out of the server project for that. Now that I mentioned already some dependencies that we use, we need to talk a little bit about Crates.io and dependency management. First of all, I want to say I think Crates.io is great in many ways. It allows for very seamless integration of dependencies into your projects. It's just one cargo add something away. However, this easiness and comfort comes with a downside. It very easily leads to a situation that I like to call the node module syndrome, where you suddenly have dependencies that have dependencies that have dependencies. And if you're not careful, you very quickly end up with a dependency tree that is very deep and contains hundreds of things you have no overview over, have not audited, and do not know about stability guarantees, security policies, and so on. And probably the biggest pushback against using more Rust in KDE I have encountered was from Linux distributions, which are somewhat at odds with Rust's ideas of dependency management because they have their own ideas of how dependency management is supposed to be done. They want to do things like build shared libraries and have them shared between projects and update them and patch them on their own cycle, and do things like security vulnerability and version tracking. And the way Rust and Cargo are designed pushes a lot of that responsibility upstream onto the application developer, which does not need to be a bad thing, but it's a sort of cultural shift that not every upstream is properly prepared for. And also, just because there is a crate on Crates.io that has the name that sounds like it would solve your problem, doesn't mean it actually will, and it doesn't mean it actually will given the constraints and considerations of your project. And since anybody can upload pretty much anything there, there's also a risk of inconsistent quality within Crates.io and the ecosystem, and also sometimes a perceived or actual lack of stability within the language and the ecosystem. Now let's talk a little bit about build systems, everybody's favorite topic. I think Cargo is a great tool for what it was designed to do, which is build your average Rust project and fetch all of the dependencies and so on. For building a C++ heavy project, it would not be my first choice. So within KDE, we've been using CMake for a while. And even if you look at the larger C++ community, it seems to be gravitating more and more towards CMake. So who of you has worked with CMake before? Who of you has liked it? For all its faults, I think CMake is a great tool for what it was designed to do, which is bring some semblance of sanity into the madness that are C++ compilers and toolchains. So I actually like using it for C++ code. Now, if we want to integrate a Rust-based project into our CMake build, we can use a tool called Corrosion, which is basically a wrapper that we can call from CMake and then takes a cargo toml and basically calls cargo, builds all the Rust stuff, and then it gets linked into your C++ project, and it works great. Now, naturally, when we have people who want to come to KDE and write applications in pure Rust with only a little bit of KDE libraries in there, they don't want to do CMake. They want to use Cargo because that's what they're used to, and that's what's working great for Rust projects. And that is, in principle, very much possible. However, one thing we found when trying to use Cargo for our cases is that while it works great for the part of creating the actual resulting binary, it's not so great when it comes to installing and creating a distributable thing, because there we want to also do things like install auxiliary files like man pages, icons, desktop files, AppStream metadata, and so on. And Cargo does not have support to do that. So one way to do that is to take another tool and wrap that around Cargo, which might as well be CMake, because CMake can do all of these things, and we have figured out how to effectively do these things with CMake in a way that other people's things like creating a packager, an installer, or Linux distributions, Yocto, and so on, can directly consume. Now, whenever we add an additional language, whether that's Rust or Python or really anything else, into an existing code base with a lot of C++, this adds complexity. And this complexity adds challenges. Some of these challenges are technical. Some of these challenges are actually social. On the technical side, the interoperability between C++ and Rust is usually pretty hard. CXX helps a lot, but it still takes you a moment to wrap your head around the concepts, and it requires a certain shift in thinking away from high-level APIs to, okay, how does this actually work under the hood, and how can I use it from both languages? On the social side, there is a certain risk of community fragmentation, because I think that one of the things that make KDE great is that there's a fair amount of technical and social consistency between different projects. So I can very easily jump between projects and effectively contribute without having to relearn a lot of things. If we now have some projects where a substantial part is in Rust or really any other language, not only am I now required to know C++ and Rust, I'm also required to learn about the interoperability between the two, which is very much non-trivial. And there is a certain risk that some of our community members will just say, no, I'm not going to engage with Rust because that's not what I know. I just want to stick with C++ because that's what I want to know. And I don't necessarily want to blame them, because if you're coming home from an 8-hour day job and just want to do a little bit of KDE fun on the side, and you now suddenly can't effectively contribute anymore, that's a big problem, and that's a big concern. On the flip side, it opens the door for new contributors who would like to work on KDE software, but don't necessarily want to work 8 hours in a day job and then open the editor and write even more C++ code. Or maybe they already use Rust in their day job and want to continue doing that when working in KDE. And it also opens some opportunities both for KDE and the Rust communities to learn from each other, because we have been doing open source and large-scale software development for 30 years. I'm pretty sure there's a thing or two that the Rust community can learn from us, and the other way around. All that said, thank you for listening to me. If you want to chat about this topic, you have some ways to contact me, or else I will be around during the conference. So, thank you.
Thank you, Nicolas. Do we have some questions for the KDE community? A few over here. Okay, we'll start here.
Hi, great talk. Very interesting as well. So I used CXX for a project where I was wrapping some C++ library to Rust, and I had some difficulty, but I made it work, and it was everything was working great, I thought I was done. But then when I pushed it to CI, it was failing and it was not linking. And then some other colleagues said the same thing on their computer. I was using Fedora, they were using Ubuntu. So I was just wondering if you have some similar difficulties with CXX and stuff, like linking especially.
It always can get a bit tricky, because we're you're relying on things like the system C++ compiler and toolchain and so on, and just having, for example, certain KDE dependencies installed in a way that CMake finds them, which is a very non-trivial thing to do. So there's certainly loads of opportunities where things can go wrong and it can get hard to debug that you don't necessarily have when you're dealing with a pure cargo setup. So yeah, there's definitely loads of complexities there and loads of opportunities for things to go wrong. But yeah, that's what I mean with interop adds complexity, and it's something we need to be prepared to handle. But I don't have very much specific advice on how to do that.
Other questions here? And Luca.
Yeah, thank you. Nice presentation. You said you have a large system, 50 million lines of C++. Mm-hmm. How large is the Rust code base? And can you comment on the different in build times? Like, is Rust build times an issue for you?
I don't have the numbers right now. I would estimate we have a couple of hundred, maybe 1,000 lines of Rust code. So it's really mostly glue code around specific crates and then bridge that to the C++ world. Build times have not so far been a big concern, but it's something that's in the back of my mind. Because, yeah, one thing that I keep hearing about and also experience with Rust is build times are a thing, but then again, build times in C++ aren't amazing either.
Okay, and over here.
So you mentioned that you've had difficulties interacting with the CXX maintainer. Have you considered the idea of maintaining a fork of that crate and perhaps grouping together with other people to satisfy whatever needs are not currently in line with the maintenance policy?
Me personally, no. Maybe ask the guy next to you.
Okay, the guy next to you.
Hi, I'm Leon, and I'm one of the maintainers of CXX Qt, so we do definitely heavily depend on CXX, and we have run into that problem as well. We are considering forking CXX, but the thing we do definitely want to avoid is an ecosystem split here, where we now have 3 different forks of CXX that multiple people work with. And at the moment, if it's just us, it would be quite a lot of work to maintain a fork, but I think it would be a great opportunity to talk about if there are more people interested in whether we can finally come up with a community-maintained version. So at least I'd definitely be open to it.
Thank you. Any other questions? No? Okay. Well, thank you, Nicolas. But, yes.